Pluto, once known as the ninth planet in our solar system, has been a topic of fascination for decades. This small, icy world has intrigued scientists and astronomers for years, yet for a long time, it was a mysterious, nearly inaccessible object at the far reaches of our solar system. In fact, the first images of Pluto were blurry and incomplete, coming only from the Hubble Space Telescope, which simply wasn't designed to capture the details of such a distant world. But all of that changed in 2015, when NASA's New Horizons spacecraft passed by Pluto, sending back unprecedented images and data that have revolutionized our understanding of this distant object. Before New Horizons, Pluto was a place of mystery. It was considered dark, cold, and lifeless, a frozen rock orbiting the Sun in the farthest reaches of the solar system. Some scientists even speculated that Pluto might be little more than an icy shell with little to no geological activity. But the images and data sent back by New Horizons shattered that perception. Pluto, it turns out, is far more complex and dynamic than anyone had ever imagined. When NASA's New Horizons spacecraft made its historic flyby in 2015, it revealed a stunningly diverse and vibrant world. The first images showed Pluto's surface to be a landscape of high mountains, vast plains, and strange, heart-shaped regions. It was a world teeming with geological features that hinted at an active and changing landscape, one that could hold the key to understanding the formation of our solar system. As scientists examined the data from New Horizons, it became clear that Pluto wasn't the dead, frozen world it had once been thought to be. Instead, it was a place of surprising geological activity and mysterious features, many of which are still being analyzed and studied today. Perhaps one of the most surprising discoveries was the presence of a large, heart-shaped region on Pluto's surface. This region, known as the Sputnik Planitia, is a vast, icy plain that is thought to be relatively young in geological terms. Its smooth, featureless surface suggests that it has been shaped by recent geological processes, rather than being an ancient, frozen relic. The fact that this region is still undergoing changes suggests that Pluto is not a stagnant, dead world but one that is still geologically active. This discovery alone changed the way scientists view Pluto, challenging their previous assumptions and sparking new questions about the planet's history and future. In addition to the heart-shaped plains, New Horizons also revealed the existence of towering mountains on Pluto, some of which rise as high as 3.5 kilometers. These mountains are composed largely of water ice, and their formation suggests that there has been significant geological activity on Pluto in the past. Scientists believe that these mountains may be the remnants of ancient tectonic activity, with icy materials pushing up from the interior to form the towering peaks we see today. The discovery of these mountains raised new questions about Pluto's internal structure and the processes that drive its geological activity. Another astonishing finding was the discovery of glaciers made of nitrogen ice. These glaciers, which stretch across Pluto's surface, provide evidence that the planet may have once had an atmosphere thick enough to support the flow of ice. As Pluto's orbit takes it farther from the Sun, its atmosphere has thinned, but scientists believe that in the past, it may have been much more substantial, allowing for the movement of ice and the formation of glaciers. The discovery of these glaciers has led scientists to reconsider the conditions that might have existed on Pluto in the distant past, and it raises the possibility that Pluto may have once been a more hospitable environment. The most surprising discovery, perhaps, was the evidence of a possible subsurface ocean beneath Pluto's icy surface. Although Pluto's surface is incredibly cold, with temperatures reaching as low as -230 degrees Celsius, the discovery of convection cells on its surface suggests that there may be some form of heat coming from deep within the planet. These convection cells, which were first observed in the heart-shaped region, are thought to be the result of heat rising from Pluto's interior, causing the icy surface to shift and move in a way that suggests geological activity. This discovery has led scientists to speculate that there may be a subsurface ocean of liquid water beneath Pluto's frozen exterior, which could potentially harbor the conditions necessary for life. But it's not just the mountains, glaciers, and possible subsurface oceans that make Pluto so intriguing. There are also signs of something even more remarkable: cryovolcanism. Cryovolcanoes, or ice volcanoes, are a type of volcano that erupts with icy materials such as water, methane, and ammonia, rather than molten rock. New Horizons found evidence of these cryovolcanoes on Pluto, with one of the most striking examples being a mountain known as Right Mons, which rises about 4 kilometers above the surrounding landscape. Right Mons is thought to be an ice volcano, and its broad summit and other features suggest that it has erupted in the relatively recent past. The discovery of cryovolcanism on Pluto challenges our understanding of planetary geology, as it suggests that there are other ways in which a planet's surface can be shaped and changed, even without the presence of molten rock. In addition to cryovolcanism, New Horizons also revealed the presence of giant dunes on Pluto's surface. These dunes, which stretch across the western edge of Pluto's heart-shaped region, are thought to be the result of winds blowing across the icy landscape. Although Pluto has an incredibly thin atmosphere, there is enough of a breeze to cause small particles of methane ice to be lifted off the surface and carried across the landscape, forming dunes that can reach up to several kilometers in size. These dunes are similar in appearance to those found on Earth and Mars, but their composition is quite different. Instead of sand, the dunes on Pluto are made of fine methane ice particles, which are lifted by the wind and deposited in the shape of dunes. The discovery of these dunes provides further evidence that Pluto's surface is dynamic and constantly changing, and it suggests that there may be even more surprises waiting to be uncovered. The presence of nitrogen lakes on Pluto is another fascinating discovery that has scientists rethinking the nature of this distant world. In 2015, New Horizons revealed a large, dark spot on Pluto's surface that appeared to be a lake. This lake, which measures about 32 kilometers across, is thought to be filled with liquid nitrogen. Despite the incredibly low temperatures on Pluto, nitrogen can exist in a liquid state under the right conditions, and it appears that this lake may have once been filled with liquid nitrogen, which could have flowed and evaporated over time. The discovery of this lake raises questions about the nature of Pluto's climate and its potential for seasonal changes. As Pluto's elliptical orbit brings it closer to the Sun, it's possible that nitrogen could melt and form liquid lakes, rivers, and even possibly other features that would shape the surface of the planet. But how could a place as distant from the Sun as Pluto be so geologically active? The answer, scientists believe, may lie in Pluto's internal heat. For a long time, it was assumed that Pluto, being so far from the Sun, would be a cold, lifeless world, with no internal heat to drive geological processes. However, the discovery of convection cells on its surface suggests that something inside Pluto is warming its icy exterior. This heat could come from a variety of sources, including radioactive decay or tidal forces caused by Pluto's unusual interaction with its moon, Charon. These forces could be generating enough heat to cause the interior of Pluto to remain warm enough to support the movement of icy materials and even the potential for subsurface oceans. This new understanding of Pluto's internal heat has opened up exciting possibilities for future research and exploration, and it has fueled the idea that Pluto may still have many secrets yet to be discovered. Pluto's atmosphere, although thin, has also proven to be a subject of great interest. Despite being only about 100,000th the density of Earth's atmosphere, Pluto's atmosphere plays a significant role in shaping its surface features. The thin atmosphere is composed primarily of nitrogen, with small amounts of methane and carbon monoxide, and it has been observed to undergo dramatic changes depending on Pluto's position in its elliptical orbit. When Pluto is closer to the Sun, its atmosphere thickens, and nitrogen and methane can condense and freeze out of the atmosphere, forming ice crystals that fall back to the surface. This cycle of atmospheric changes helps to shape the surface of Pluto, creating the varied landscapes that we see today. As the data from the New Horizons mission continues to be analyzed, scientists are uncovering more and more about Pluto's surface, atmosphere, and potential for life. The discoveries made by the New Horizons probe have not only changed our perception of Pluto, but they have also opened up new avenues of research into the outer solar system and the possibility of life on distant worlds. While Pluto may no longer be classified as a planet, it remains one of the most intriguing objects in our solar system, and its mysteries are far from solved. What is clear, however, is that Pluto is no longer the lonely, lifeless world that it was once believed to be. Instead, It is a dynamic, geologically active planet that holds many secrets waiting to be uncovered. The discoveries made by New Horizons have given us a glimpse into a world that is much more complex and fascinating than anyone could have imagined. As we continue to study the data from the New Horizons mission, we are only just beginning to understand the true nature of Pluto and its place in the solar system. It is a world that is rich in surprises, and it is a place that will continue to inspire awe and wonder for years to come.